Hey guys, Mr. B here, bringing another math video. In this video, I'm going to talk to you about the derivative of y is equal to e to the x. So this is one of those things that pop up a lot in calculus, the function e to the x, and it's just a special exponential function that has a good connection to logs, basically. So you need to know the derivative of it. If you're looking for the proof, I'll put a description. In the description, I'll put the video I have for the proof of this guy. But in all honesty, at the end of the day, you just really need to know how to use this thing. So the derivative of this guy is, well, drum roll, itself. Doesn't change. The derivative of e to the x is e to the x. It's really the easiest derivative ever. It is absolutely the easiest derivative ever. So my students prefer a different form of this. So they usually like e to the u is equal to e to the u times u prime, because you're much more likely to see this guy with something other than x as its exponent. So let's do two examples of this and sort of an introduction to where you might see this. So let's look at this example. Y is equal to e, and instead of x, I'll write x to the 7. So I go ahead, I take my derivative, I recognize that my first part of my derivative is e to my u, so essentially whatever you get when you're taking the derivative of this guy is you always rewrite it, and then you just take the derivative of what's in the exponent. So a lot of my students like to write my u prime like this, although you can definitely get there in one step with this. So e to the 7, x to the 7, and the derivative of x to the 7 is 7, x to the 6 using my power rule. And then I'll just rewrite this. I like to have my e to the x last. And there it is. So there's my derivative of e x to the 7. So a lot of times you'll see this mixed with trig functions. So let's do an example with trig. So y is equal to e to the sine. And let's do this chain rule within a chain rule kind of thing. So we got a chain rule and then a chain rule within a chain rule. So first thing I need to do is I need to take the derivative of my outside function, which is my e to the x. So the derivative of e to the x, or e to the u, is e to the u times u prime. So it's e to the sine x squared. So we always just rewrite it and then take the derivative of whatever is in my exponent. Now the thing about this guy is that's a chain rule itself. So now we go ahead and rewrite again. E to the sine x squared, and the derivative of sine is cos, so it becomes cos of x squared times the derivative of x squared, which again you could have done in this step if you wanted to. And then we have e to the sine x to the 2 times cos x to the 2 times x, the derivative of x to the 2, which is 2x. And then the only thing I can really do with this is just rewrite. So I will write 2x cos x squared times e to the sine x squared. I usually write my e to the whatever last. Again, that's just a personal preference. I don't know if there's any generalized rules about that. Well, guys, this is the derivative of e to the x. You can see it's the easiest derivative ever, but they can get some complicated scenarios. If you need a proof, check out one of my other videos. Thank you guys for watching. And I'll see you guys in class. Like, share, subscribe. Thank you.